Assalamu alaikum. So from this video onwards, I'll be making a series of videos on the O-level topic for chemistry, electrochemistry. So we have electrochemistry. Now, as you can see here, this is the first video of this chapter, and this probably will be the longest video in the entire playlist, and that's because I will be giving an entire chapter overview in this, and I'll be introducing all the important terms that we'll be coming across in this chapter in this video. So hopefully the videos that will come after this video will be shorter and more specific, because this is a very general video, so it will be longer, but it will be worth watching the whole thing. So please go through the entire video so that you have a very sound foundation on which you will to build on. Right. So as the name implies, it's a very simple name, electro and chemistry. So this is basically a field of chemistry that deals with the interaction between electricity and chemicals. So it's a field of chemistry involving the interaction of chemistry of chemicals and electricity. At our level, we will be dealing primarily with two aspects of electrochemistry, the first of which is electrolysis. There's another aspect as well, and I'll just come to that near the end of the video. So now, let's take a look at electrolysis. Let's dissect the name again. So here we can see we have electro here, and we have lysis. This is the other part of the name. So electro is again electricity, and lysis means breakdown. If any one of you is studying biology, then in the chapter on diffusion, osmosis, and active transport, you would have come across what happens when an animal cell is put in pure water. The pure water, having a higher water potential, tends to move into the cell, and the cell, since it does not have a very rigid membrane, the cell membrane is a very fluid structure, so because of the continuous entrance of water, the cell bursts. The bursting of a cell is called lysis, that's breakdown. And if we are talking about red blood cells, that's called hemolysis. That is the breakdown of red blood cells. Heme is basically the heme part of the name comes from the hemoglobin that's contained in the red blood cells. Anyway, that's biology. Let's leave that aside. If I ever make a biology video, I will discuss that then. Right. So electrolysis means breakdown using electricity. So what is it that we are actually breaking down? We are breaking down ionic compounds. So the formal definition of electrolysis therefore becomes, it is the breakdown of ionic compounds. This is the key. Using electricity. So basically, if you have seen my video on salts, you would have seen that, and you would be knowing that an ionic compound is basically made of a cation and an anion, both of which are linked together by strong electrostatic forces of attraction. Now, if you go back to the chapter of elements, mixtures, and compounds, we have studied there, or you would have studied there, that a compound is a pure substance which is made by chemically combining certain elements together. So, an ionic compound is a compound again which is made by the chemical combination of cations and anions. Cations and anions, and both of these are held together by strong electrostatic forces of attraction. And back in the same chapter, we had studied that mixtures are not chemical compounds. They are made by physically mixing things together. For example, you take salt, you take water, you mix them together. You get a salt solution. That's a mixture. Likewise, I take sand and iron filings and shake them together. This, of course, is not a mixture. This, of course, is not a compound. It's again a mixture. And we had studied that mixtures can be easily separated through simple physical means. However, the same cannot be said for compounds. That is, if I have, for example, solid sodium chloride, which is actually made of sodium ions and chloride ions, both of these being held together by electrostatic forces of attraction, I cannot simply take this apart through physical means. Instead, I have to use chemical procedures to separate sodium and chloride from each other. And this electrolysis is actually the chemical procedure that will be used to separate the cation from the anion. So here we have the cation, here we have the anion, and both of these will be separated using electrolysis. Right. So therefore, now since we are passing electricity through an ionic compound in order for electrolysis to occur, the first requirement of electrolysis obviously is going to be a source of electric energy, that is a battery. So I'll just make a heading here, requirements of electrolysis. Requirements of electrolysis. So the first requirement is a battery, or we can say any source of direct current. Now, if you are a physics student, you'll know that we have two types of electric current. One is direct current and the other is alternating current. We won't use we won't use alternating current here at or any cost. And the reason I'll tell later, because you won't be able to understand the reason at this point of time. But this is something that you must remember, that you need to have a source of direct current. So this is the key. I'll mention this here for you, that we cannot use an AC supply, alternating current supply. Right. Now another very important thing, and listen to this carefully because this is one of the most favorite MCQs of the CIE examiners. We know that electrolysis is breaking down an ionic compound using electricity, and for that we need to provide electricity from a direct current source. That means we have to pass electricity into an ionic compound for the breakdown to occur. And thus, the ionic compound should be a conductor of electricity. Otherwise, the circuit won't be complete, the electricity won't be able to pass through, and the breakdown won't occur. But there's a problem here. The problem is that in an ionic compound, as we can see here, the cations and anions are linked together through strong electrostatic forces of attraction. So what happens is that electricity, basically, electric current to be more specific, it is the flow of electric charge. Right. So because it's the flow of electric charge, but in an ionic compound, the cations, which are positive ions, and anions, that's negative ions, both are tightly held together in their positions by strong electrostatic forces of attraction. That means a solid ionic compound does not have any free charges, and therefore a solid ionic compound cannot conduct electricity. For that means that if I have a solid crystal of sodium chloride and let's say I connect it to a battery, and here I have a bulb to see if it lights up or not. This bulb will not light up. Why? Because there are no free ions. So let's write this entire thing here. Right. For electrolysis to occur, okay, not even this. Right, so I'll type this stuff here. That'll be easier. Electric current is the flow of electric charges. And this is actually why metals can conduct electricity. In the chapter on bonding, you would have studied about metallic bonding. What is metallic bonding is that in a metal, you have positive ions that are surrounded by a sea of electrons. Now, when you connect a piece of metal to a battery, what happens is that the sea of mobile electrons continues moving, and this movement in a specified direction allows electric current to flow. So, electric current is a flow of electric charges. This explains. I think if I can make the font size smaller, that will be good. Alright, forget it. This explains why metals can conduct electricity. Electricity, since they have free electrons. However, in solid ionic compounds, the cations and anions are bound tightly to each other by strong electrostatic forces of attraction. Therefore, a solid ionic compound has no free charges and hence does not conduct electricity. So that's it. You can write this down with you. This is important. Now, what's the question that you will often see in the examinations? In MCQs, what they do is that they'll ask you which of the following substances is not a conductor of electricity. So the question will go something like this. The options will go something like this. You will have a metal. You will have an aqueous solution of an ionic compound. For example, he'll say hydrochloric acid. That's an ionic compound and it's an aqueous solution. Remember, aqueous solutions of ionic compounds are conductors. We'll come to that later. And then they might be having maybe a non-metal that's a conductor, for example, graphite. It's not a metal, but it's a conductor. And then in the end, they might be having a solid ionic compound, for example, sodium chloride. And that solid ionic compound is going to be the answer to the question. Why? Because of the reason that I have just written here. So now this reason that I have just given here, this is a major limitation in how electrolysis can be carried out. Why? Again, I'll just review this a bit. For electrolysis to occur, we need to pass electricity through our ionic compound, and in order for electricity to be able to pass through the ionic compound, we need to have free charges, and there are no free charges in solid ionic compounds. Therefore, we are at a dead end. And in order to counter that dead end, there are two possibilities that we have. That is, that firstly, we can melt this ionic compound and use a molten solution. Sorry, use a liquidized form of this ionic compound. In liquids, what happens is that these electrostatic forces are not as strong, and that's why it exists as a liquid. Remember this, these electrostatic forces play a very important role in holding the strong lattice structure of the ionic compounds. Once we reach a temperature high enough to be able to melt the ionic compounds, these electrostatic forces of attraction are lost, and therefore is the solid constituency of the ionic compound. We now have free ions in the liquid which have the ability to conduct electricity. So this brings us to the second requirement of electrolysis, and that is an ionic compound which conducts electricity. Such an ionic compound is called an electrolyte. Right. So what is an electrolyte? An electrolyte basically is a liquid which conducts electricity. Is it's something in liquid phase. I'll just tell you what phase means. It is a substance in liquid phase that conducts electricity. And why does it conduct electricity? We just mentioned here because of free ions. On the basis of free ions. Therefore, mercury will not be called an electrolyte, even though it's a liquid, but it is actually a liquid metal. And metals have free electrons, not free ions. Therefore, mercury is not an electrolyte. However, if we melt sodium chloride, we'll have sodium ions and chloride ions in the liquid. That is going to be an electrolyte. Similarly, if we dissolve sodium chloride in water, we'll have free ions in the solution. How? We'll discuss that later in this very video, inshallah. No, not in this video. But it'll be an electrolyte. It'll conduct electricity. Now, what do we mean by liquid phase? I mentioned the word phase here. So I'll just move to one side of the board and mention this here. So we know that there are three states of matter: solid, liquid, and gas. Now, solid refers to any solid, for example, a wall in front of you, the table on which you have kept your exercise books and you're writing, if you are taking notes, that is, the pen that you are holding, the solid sodium chloride salt is a solid, ice in the fridge is in the deep freezer is a solid. However, the term liquid is a bit limited. Liquid refers to, in terms of chemistry, I'm talking about chemistry. Liquid refers either to liquid metals or liquid compounds only, right? So liquid is a term that is used only for pure substances. And from the chapter of elements, mixtures and compounds, We know that pure substances are only elements and compounds. So, liquid elements are mercury. Likewise, you have bromine, it's a liquid element, and there might be others as well. So, if you see mercury or you see bromine, you'll call those liquids. Similarly, we can have liquid compounds as well. For example, water, or water is liquid. And then we have, I can't get examples in my head right now. The second possibility is melting solids. For example, if I have here, let's go here, sodium chloride. We know that sodium chloride solid can't conduct electricity. However, if we melt sodium chloride, it will conduct electricity. So, sodium chloride, when it's molten, it will be a liquid. Again, it's a pure substance. Why? Because the molten sodium chloride, after all, is just sodium chloride, no other impurities. So, liquid is a term used only for pure substances. However, if sodium chloride is mixed with water and we make a solution of sodium chloride, that is not a pure substance. Why? Because that solution contains both water and sodium chloride. So it's a mixture basically. No? So because of that, we refer to such mixtures as aqueous solutions. So if we have sodium chloride plus water, that will not be called a liquid in terms of chemistry. Instead, it will be referred to as an aqueous solution. Now, this classification, the problem that the term liquids was used only for pure substances and aqueous solution is a term used for mixtures, this caused problems to the chemists. So they made a term that encompasses both of these. And that term is phase. Liquid phase. So we can say that liquid phase is a term that encompasses both pure substances like water or molten compounds and aqueous solutions. Coming back to electrolysis, I mentioned that the second requirement of electrolysis is an electrolyte, and an electrolyte is defined as a substance in liquid phase that conducts electricity. So by using the word liquid phase, I mean that I'm sorry for this problem that I'm facing a bit. That's fine. So by using the term liquid phase, I have implied that an electrolyte can be a molten ionic compound, which is of course a pure substance, or it can be an aqueous solution as well, which is not a pure substance. And as we proceed with the chapter, we'll see that the electrolysis of molten ionic compounds and aqueous solutions is different. Alright, so now we are done with two things here. We know that what electrolysis is. We discussed that it's the breakdown of ionic compounds using electricity, for which we need to pass electricity through the ionic compound which we cannot do with a solid ionic compound. The reason being that there are no free charges in solid ionic compounds. For this reason, we have to either melt those ionic compounds or dissolve them in water, which in turn is going to give us the free ions, which will conduct electricity, and thus the breakdown will occur. The liquid through which electricity will pass is called an electrolyte, which is a substance in liquid phase that conducts electricity on the basis of free ions. And as I told, liquid phase is a term that encompasses both pure substances and liquid mixtures. That is, an electrolyte can be both a molten ionic compound and an aqueous solution of that ionic compound. Now we have the last requirement left. Now before we get to that, yeah, there's some small physics that we'll try to recall. Let's draw an apparatus that we can use to test whether a particular substance conducts electricity or not. So we can have a battery here. Then let's take a bulb. If this bulb is going to light up, then the substance under test is a conductor. Otherwise, it's not. And then here what we'll do is, here's one clip, here is another clip, and here are our connecting wires. Now what we can do is that we'll place the substances under test between these clips, and if the bulb lights up, this substance that we have put here is a conductor. Otherwise it's not. We can make a similar apparatus to test whether something in liquid phase is a conductor or not. So what we'll do here is that here is a battery. We'll place our bulb again to test whether the conduction is taking place or not. And here I make two rods instead of the two connections of the clips. And I'll just tell you why. Here we go. So now you can see that the clips have been replaced by rods made of conductors. These rods are made of conducting materials like metals, or we can also have graphite here. These rods will basically be dipped into the solution under test. So let's have the solution under test here. And the reason why we didn't dip clips and we used big rods instead was to improve contact with the liquid. See, these clips are very small and ions are dispersed throughout the liquid. So we need a larger area to ensure contact with the liquid. If this liquid is a conductor, it will be called an electrolyte, right? Ions will be dispersed throughout the electrolyte. Therefore, we need something which has a larger area than the clips so that conduction is better and more complete. So I guess I should write this down here. Clips have been replaced by rods by conducting rods to improve contact with the ions in the electrolyte. So now since the electrical contact, here is our source of electricity, and the electrical contact of this liquid with the electrical source is through these rods. These rods are called electrodes. Right? These are rods. These provide electrical connections. And this ES is for plurality, and I don't know why this E is here. Anyway, these rods are referred to as electrodes, and these are the third requirement of electrolysis. So, third requirement of electrolysis are electrodes. And what are electrodes? These are conducting rods through which the liquid under test, the electrolyte, we will be more specific, through which the electrolyte is connected to the power supply. So we have three requirements of electrolysis. The first is a battery, or to be more precise and more general, we can say any source of direct current. We cannot use an AC supply. We'll come to that shortly. The second requirement is an electrolyte, which is a substance in liquid phase that conducts electricity on the basis of free ions. And the third are electrodes, that are conducting rods through which electrical connection is established between the battery and the electrolyte, as we saw in this diagram. So if this liquid here is a conductor, the bulb is going to light up. And I'll just mention another thing here. The better a liquid is at conducting electricity, the brighter the bulb will light up. So a stronger electrolyte will be a better conductor than a weaker electrolyte. For example, if we talk about a weak acid like ethanoic acid, all acids are electrolytes, remember that. So, ethanoic acid is a weak acid. And from the chapter of acids and bases, we know the definition of a weak acid. A weak acid is a substance that is only partially ionized in aqueous solution. So, it has very few ions, and thus it's a weak electrolyte. The bulb wouldn't light up as brightly as we have shown here. There might be probably just a a very dim light will be produced. However, if we use a strong acid, for example, hydrochloric acid or sulfuric acid, or if you're using molten sodium chloride or a concentrated solution of any other salt, that has a lot of ions. And therefore, in that case, it's going to be a good electrolyte, a strong electrolyte, and hence we will see the bulb glowing up more brightly. Now, things are not as simple as it might be seeming here. Because if you look at these electrodes, like it's not very difficult as well, so sorry for my previous statement. If we look at the electrodes, we can classify the electrodes on, on the basis of two parameters. The first parameter is the chemical reaction that occurs on each of the electrodes. We'll go down here, and here we go. Electrodes can be classified on the basis of two parameters. The first parameter is the chemical reaction that takes place at that electrode. And the second parameter is the substance with which that electrode is made. With which that electrode is made. So let's talk about this first. Now, as you can see here in this diagram, one of the electrodes is connected to the positive terminal of the battery, and the other electrode, if we remove the bulb from here, the other electrode is connected to the negative terminal of the battery. And because of this difference in between the connections, slightly different reactions will be taking place at each of these two electrodes. So taking a small jump here. Things will become clearer as we move on with the videos. Basically, there are two chemical reactions that take place, and you have studied those chemical reactions before. One is oxidation, and the other is reduction. On one of the electrodes, oxidation will take place, and on the other, reduction will take place. The electrode at which oxidation takes place is called the anode, and the electrode at which reduction takes place is called the cathode. This ode comes from electrode, and this an and cath have a very nice significance. I'll just come to that in a while. So now, how to remember which reaction takes place at which electrode? Well, there's a very nice technique here. If you're a football fan, then you will know that one of the greatest players of all time is Cristiano Ronaldo. So, and he is abbreviated as CR. Let's forget the 7 that comes in his name, in the abbreviation to his name. So, if you can remember CR, Cristiano Ronaldo, you will remember that at the cathode, reduction takes place, and therefore, at the anode, oxidation will take place. There's another way that you can remember it, and that is that C, A is a vowel, and so is O. C is a consonant and so is R. So this can also be a way to remember the reaction that takes place at each of the electrodes. Now remember this. If whenever in the paper you are asked to define what an anode is or what a cathode is, this is the definition that you're going to give. Right. Now coming to the significance of an in anode and cath in cathode. When we started off with electrolysis, I told you that electrolysis is a method of breaking ionic compounds down to produce cations and anions, right? That means that an ionic compound is basically made up of cations and anions. What happens is that when we pass electricity through an ionic compound, uh, some ions will move to the positive electrode and some ions will move to the negative electrode. Now let's look at this diagram here. We see that this is the positive electrode and this is the negative electrode, right? So what happens is that we know that opposites attract each other. So if this is a positive electrode, what's going to move here? Yes, the negative ions are going to move to this electrode. And what are negative ions called? Negative ions are called anions. So, anode is the electrode along which to which anions move. Anions move to the anode. And when we are talking about electrolysis, the anode is the positive electrode. That is why negative ions are moving to the anode. But remember, once again, I'm telling you this, that if you are asked to define what an anode is, you will not say that it is the positive electrode. Instead, you are going to say that anode is the electrode at which oxidation takes place. The reason is that when we'll come to the other branch, which I have yet left unmarked here, we will see that there is a difference. At that point, in that other branch, we will see that anode will be the negative electrode. However, in electrolysis, yes, it's true that the anode is the positive electrode, but it's not always the case. Why? Because in the other branch that I have not yet filled, we will see that anodes are going to be the negative electrodes there. Electrolysis may positive, and in electrochemical cell, that is the other branch that I'm filling soon, inshallah, it's going to be the negative electrode. Likewise, cathode is the electrode to which cations move. So, cations move to the cathode. Now, let's take a look here. Here is our negative electrode, and we know that opposites attract. So, positive ions in the solution are going to move to this electrode, and positive ions are called cations. Again, if you are asked to define what a cathode is, you will not say that the cathode is the negative electrode. Why? Because again, when we'll come to electrochemical cells, you will see that the cathode there is going to be the positive electrode. But one thing's constant, and that is that reduction is going to take place at the cathode no matter what. No matter you have an electrolytic cell or you have an electrochemical cell. Alright, since I've used the term here, electrolytic cell basically, electrolytic cell. It's nothing, it's just a terminology, it's a fancy terminology to refer to the apparatus of electrolysis. Apparatus of electrolysis is called an electrochemical cell. Sorry, electrolytic cell. And it has three things. A battery, number two, an electrolyte, and number three, electrodes. Connecting wires are too obvious a thing for any electrical circuit, therefore I have not mentioned it here. Right. Now, since I have made mention to oxidation and reduction, then it will be good to have a small review of what oxidation and reduction actually are. So, from the chapter on oxidation and reduction reactions, you would have studied that oxidation and reduction. Oxidation is gain of oxygen, and reduction is loss of oxygen. Then oxidation is loss of hydrogen, and reduction is gain of hydrogen. Then number three, oxidation is gain in oxidation state or oxidation number, and reduction is loss in oxidation state. And finally, the fourth thing, oxidation is loss of electrons, and reduction is gain of electrons. When we are talking about oxidation and reduction in the chapter of electrolysis, it is this last point that is very important to us. We'll be talking about oxidation and reduction in terms of gain or loss of electrons. Now, let's try to understand what happens in an electrolytic cell. Now see, remember this. There's another thing that I'd like to tell you, that electrolysis starts at the anode. Electrolysis. Again, this is not a definition. This is something that's going to help us as we solve the problems on electrolysis in the later videos, inshallah. Electrolysis starts at the anode. Now what happens is that negative ions move to the anode. And why is a particular ion negative? The reason is that it has excess electrons to it. Let's take a simple example of chloride. Chlorine becomes chloride when it gains electrons. So, when something is an anion, it definitely means that it has gained excess electrons, right? One chloride ion has one excess electron, one more electron than the protons it possesses. So when a negative ion moves to the anode, it is going to lose the excess electrons. The excess electrons will be lost. And at which electrode is all this happening? At the anode. And we mentioned here that anode is the electrode at which oxidation takes place. And oxidation is loss of electrons. So these anions lose their excess electrons. These excess electrons move through the external circuit. Here they go, here they go, here they go. And they reach the cathode. Now at the cathode, there are positive ions. Why is a particular ion positive? The reason is because it has lost electrons. Taking the example of sodium. Sodium becomes a sodium ion when it loses one electron. That means cations are electron deficient. So what happens is that the cations, which are electron deficient molecules, move to the cathode, and here they combine with the electrons which started their journey from the anode all the way to the cathode. So the electrons are gained by the positive ions, and gain of electrons is reduction. So this is what exactly happens in an electrolytic cell. We'll do more questions on this later, and you will get the idea better. So the first classification of electrodes is complete. That is on the basis of the chemical reaction that takes place at that electrode. Let's review this again. We have two electrodes. One is called the anode and the other is called the cathode. Uh, the anode is the electrode at which oxidation takes place, and cathode is the electrode at which reduction takes place. The second thing, anions move to the anode and cations move to the cathode. The third thing, in terms of when we are talking about electrolysis, the anode is the positive electrode, and since opposites attract, anode being the positive electrode attracts negative ions. Likewise, the cathode attracts positive ions because it is the negative electrode in electrolysis. Not all the time, not the entire chapter of electrochemistry. And the third thing, that the electrolysis reaction starts at the anode. We'll start at the anode. The negative ions that move at the anode will give out their electrons, the excess electrons that they have. Those excess electrons, here we can see in this diagram, those excess electrons move into the external circuit and travel all the way to the cathode, where where these excess electrons are gained by the electron deficient cations in reduction. Now the second classification of electrodes, that is on the basis of the substance with which that electrode is made. We know that an electrode has to be a conductor. But now we have two things here. Either we can have an inert electrode or we can have an active electrode. An inert electrode, basically, the word inert refers to unreactive. So, an inert electrode will be an electrode that does not take part in the reaction itself. It does not take part in the reaction itself. Whereas active electrodes, they take part in the reaction themselves. An active electrode does take part in the reaction itself. So when is an electrode called an active electrode and when is it referred to as an inert electrode? It's simple. See, let's say I have an aqueous solution of copper sulfate and I want to electrolyze that solution. Here I have copper sulfate. It's a blue solution. This is copper sulfate solution in a, so we'll write aqueous here. And then here we have electrodes. And here's the battery. Now I've drawn black electrodes here because I want to show that these electrodes are actually made of graphite, right? These electrodes will be referred to as inert electrodes because these will not take part in the reaction. Let's replace the electrodes with maybe platinum electrodes. Again, these electrodes will be referred to as inert electrodes. Now let's replace these electrodes with, I have a shortage of colors. I don't know what color will this turn out to be. Let's replace this with gold. Alright, so maybe just think that this is gold. Let's replace this with gold. Right? Again, these will be called inert electrodes. Now finally, let's replace these electrodes with copper. Now these electrodes will be referred to as active electrodes, right? Therefore, an electrode is referred to as an active electrode when it is when it is the parent metal of the compound being electrolyzed. That means, in other words, if a salt solution or if a salt is being electrolyzed using electrodes of the same metal that uh, of the metal which was basically formed by the same metal. I have messed up the words completely, really sorry for that. Anyway, if the metal used as the electrodes is the parent metal of the species that is being electrolyzed, that electrode is referred to as active electrode. And again, there's a difference between the reaction that takes place when we have an inert electrode and when we have an active electrode. Finally, the last thing in this video, and that is the small part that was actually left. So this was basically all about electrolysis that we just covered. In electrolysis, what we did was that we had an ionic compound, we provided electricity to that ionic compound and broke that ionic compound into its constituent elements. Here, in here we have the second thing, that is an electrochemical cell. What we are going to do here is that we are going to use chemicals to produce electricity. Chemicals to produce electricity. And how will we do that? We'll come to that in the next videos. So let's summarize what we did in this video and tell you and give you an overview of what to expect in the coming videos. So the subtopics of this chapter of electrochemistry are: number one, electrolysis. I'll do it on another side of the board. So here we go. Number one, the first subtopic of electrochemistry is electrolysis. And electrolysis, what are the things that we need to know? Alright, there's one thing that I forgot to tell you. I told you that we cannot use an AC supply here. In electrolysis, we cannot use an AC supply. Why is that so? Let's take a look at this diagram again. In direct current, what we have is a very strong sense of directionality. We have a fixed a positive terminal, we have a fixed negative terminal, and because of this, we have fixed electrodes. Like, by fixed electrodes, I mean we have fixed charges on electrodes. As a result, no matter what, negative ions only are going to move to this electrode and positive ions only are going to move at this electrode. However, in case of alternating current, what happens is that alternating current basically flows in cycles. That is, that if in one cycle this electrode is positive, this is the positive terminal and this is negative terminal, then in the next cycle this is going to become the negative terminal and this is going to become the positive terminal. And then in the next cycle again there will be a reversal. As a result, what will happen is that the electrodes will never have a permanent positive or permanent negative charge. For electrolysis to occur, we need to have all cations moving in one direction and we need to have anions all moving in one direction. If we use an AC supply, what will happen is that there will be a constant alternation between positive and negative electrodes. That is, if at one instance this electrode is positive, then at the other instance this electrode would be negative. And as a result, we will not be able to achieve the directionality that we want. That's the reason why we cannot use an AC supply. Right, coming to the subtopics that we are supposed to cover. So, electrolysis is basically about the breakdown of ionic compounds using electricity, and we studied about the need of DC supply. We discussed about electrolytes, and what we need to discuss is they can be molten compounds, molten ionic compounds, or aqueous solutions. And in the next videos, we will be discussing the differences in electrolyzing molten ionic compounds and aqueous solutions. Difference between electrolyses of the two. This is the plural basically. Right, then we discussed about electrodes. And we can have, we discussed the classification of electrodes into cations and anions. Sorry, cathodes and anodes. Cathode, anode. And we discussed about inert and active electrodes. And we'll discuss the differences in electrolysis, differences between electrolyses using the two. We will also discuss the uses of electrolysis via active electrodes. And there are two very important uses, that is electroplating and purification of metals, which we'll cover in later videos. The second class thing that we'll do in this chapter on electrochemistry is electrochemical cells. And we are going to discuss fuel cells as well. Now, for before you watch the next videos, I would like that you guys review how to write ionic equations, because after that, after this video, we'll be dealing with a lot of ionic equations, and you need to have a very good grip on how to deal with ionic equations, how to balance ionic equations, and how to write overall equations. For this video, that's all. We'll meet in the next video, inshallah. And in the next video, we'll be discussing how to electrolyze molten ionic compounds. And it's going to be a small video, so you can be a bit relaxed. Assalamu alaikum.